Today we're going to learn how to find the dot product of two vector quantities. Dot product is also known as the scalar product, and we call it the scalar product because what you're doing is you're multiplying two vectors in such a way that the answer is a scalar quantity. And yes, this happens because if you look at physics, for those who do physics, remember we learned that work done is a scalar quantity, but you actually find work by multiplying two vector quantities. So the vector quantities are force and the distance moved in the direction of the force, which are two vector quantities. And then when you multiply them, you get a scalar quantity. So let's start with how do we find the dot product of vectors. So if we have A being x1i plus y1j and B is x2i plus y2j, A dot B will be when we multiply our x's together and we add it to the product of our y's. Okay, so let's do an example. If I have vector u being equal to 3i plus 9j and vector v being equal to 6i plus 5j, right? Then u dot v will be 3 times 6, which are our x's, plus 9 times 5, which are our y's, and that is 18 plus 45, which gives us 63. Two vectors multiplied and we have a scalar. Let's do another example. If A is negative I plus 5j and B is negative 6i minus 2j, then what is A dot B? A dot B would be negative 1 times negative 6 plus 5 times negative 2, and that would be positive 6 plus negative 10, which is negative 4. So this is how you do the dot product when you are given your vectors in the ij form. It can also be used if it's in the column form. It's the same. X's, coefficients of i's, multiplied together and added to the product of the y's. Okay, if you want, you can pause the video now and go practice some examples or exercises in your textbook so you can get the hang of finding the dot or the scalar product of two vectors. Okay, let's move on to how and when do we use the dot product. We are going to use a dot product for us to find angles in between two vectors. And as you can see here, we have a formula, the cosine of theta, where theta is the angle between the two vectors. And we have two scenarios where you have A and B moving away from the same point and A and B going towards the same point. So the angle formed between them there, which is theta, is equal to the dot product divided by the product of the individual magnitudes. So let's use an example for us to see how this formula works. So if I have two vectors, A, which is 2i plus 3j, and my second vector B is negative I plus 2j. Sorry, it's supposed to be a j. And we are asked to find the angle between A and B. So for us to do this, our formula requires two things. The first thing is the dot product, and the second thing is the magnitude of A and the magnitude of B. So let's do the dot product first. Remember, the dot product is when you take the x's and multiply them, add the product of the y's. So a dot b will be 2 times -1, because it's 2i, -1i, plus 3 times 2. So that now gives us -2 plus 6, which gives us 4. So that's a dot b. Now the magnitude of a will be the square root of 2 squared plus 3 squared, which is the square root of 4 plus 9, which gives us root 13. And the magnitude of b, right, is the square root of -1, we square that, plus 2 squared, which is the square root of 1, plus 4, which is the square root of 5. So if we take these two things we found, the dot product and the magnitudes of a and b, and we place it in our formula, then cosine theta will be a dot b, which we found to be 4 over here, over the square root of 13 times the square root of 5. So that is 4 over the square root of 13. 5s are 65. So that is approximately 0.496, giving us theta to be the cosine inverse of this, which makes it 60.3 degrees. So the angle formed between a and b, the vectors, will be 60.3 degrees. So that's how you find the angles between two vectors using dot product. Now, looking at the formula, we can see that if theta is 90, meaning that the vectors are perpendicular to each other, if theta is 90, the cosine of 90 is 0. So that would mean for any fraction to be 0, its numerator has to be 0. So therefore, a dot b is 0 when the angle between the two vectors is 90 degrees. Or we can say that, let me change the color here, if a dot b equals 0, then a is perpendicular to b. So diagrammatically, it's our right angle. That will give you a dot product or a scalar product of 0 when they're perpendicular to each other. And we can use this rule to solve many problems. Sometimes they may ask you to find the area of a triangle or something like that, but you use the knowledge that a dot b is 0 when the two of them are perpendicular. Okay? And then now let us use everything we've learned in scalar product to solve problems.